that given your channel having a width of W, this width, of W, let this length be L, channel width and channel length, right? There is oxide layer above this. There is an oxide layer. Let this have a thickness of tau. What is tau? Oxide layer thickness. Tau ox. You getting it? So what is your tau ox thickness of the oxide layer? What is your oxide channel on one side, gate on the other side? What does it form? Gate oxide channel, what does it form? One side gate, one side channel, one side oxide. What does it form? It forms a capacitance. It forms a capacitor. Why? Because oxide layer is dielectric, gate is a good conductor, channel is a good conductor, so it forms an excellent capacitance. You getting it? So given that my capacitance is formed because of my gate, channel and such things, and the oxide dielectric, this is my dielectric, this is my channel, and this is my gate. What is your current expression I equal to? What is the expression for the current I? The current I is equals Q by T. What should be the Q here? Q is capacitance C into the voltage that you are applying V, which is different at different X values. The voltage is different. Why is it different? Because the gate has some voltage and your drain has some voltage and your source is at some other voltage. So the drain source voltage is variable, decreasing from right to left. So gate channel voltage is variable, V of X. By what is time? Time is length by velocity, mu into electric field. So what is I equal to? Q by T, which is C into V of X, by L into mu into E. Any doubts? So your I is therefore mu into C into W and divide with W, mu into electric field is dV by dx into V of X. You got it? Mu C into W by W into L. So what is this capacitance per unit area called as? C per unit area. Capacitance per unit area, W into length. Area of the plates, W into length is area of the plates. C per unit area is C by W into L. That's called as COX. Capacitance per unit area. Capacitance per unit area. So I is equals mu into COX into W into there's two mu's repeated, right? By mistake here. What is V of x? What is V of x? What is V of x is I is equals mu COX into W, right? Into what is V of x? It is VGS minus VT minus the voltage V. Which voltage? The drain source voltage, which is variable. So what is V of x? Voltage across the gate and channel. So it is VGS minus VT minus V into dV by dx. Any doubts? So I is therefore, I into dx is therefore mu into COX into W mu into COX into W into VGS minus VT minus V into dV, where this V is a variable it's a variable 0 to VDS. The V is the variable which goes from 0 to VDS. 90% of the derivation is over with this. If you got any doubts, ask me now. 90% of this derivation is over. If anybody has got questions, ask me. So the summary of the discussion is, this is V, the variable. What is the voltage I am giving here? VGS minus VT, something which is greater than VT. So what is the overall voltage across the dielectric? The voltage across the dielectric is VGS minus VT minus V. So this I have to integrate from 0 to VDS. So when I integrate this, I will get I into length is equals mu COX into W into VGS minus VT into V minus V square by 2, 0 to VDS. Any doubts? Any questions? So IDS is therefore mu COX into W by L into VGS minus VT into VDS minus VDS square by 2. This is for linear region, or what I call it as ohmic region. This is for linear region, where ID is depending on VDS as well as on VGS minus VT. So it's linear region or ohmic region. What if it is saturation region? If it is saturation region, saturation starts when VDS is equal to VGS minus VT. Saturation starts from VGS minus VT equal to VDS. Then what is your IDS? mu COX into W by 2L VGS minus VT whole square minus whole square by 2, so by 2. You following? I said 20 minutes. You finish off in 7 minutes. You got my logic? So what is the saturation region's identity? How do you identify saturation region? IDS is independent of VDS and it depends only on VGS minus VT. This is how you identify saturation region. This is the identity for saturation. What about for linear region? Your IDS depends on VDS as well as VGS minus VT. If you remember, this is what I showed you. Linear region, then saturation region. Any questions? Any doubts? After such an innocent theory, learning such simple topics, learning formulas, derivations, then your trouble starts. Your trouble starts with problems. So tomorrow's class will be doing completely problems. Then after that we will go to biasing circuits, amplifier working, operating point, AC analysis, DC analysis, and after that you will say BJT is damn simple. Because MOSFET will be so horrible. After I finish MOSFET and I go to the next topic, then you will say MOSFET is simple. You got my logic now? So see you tomorrow. See you in the next class.